Silence, distance, pressure. Have you ever had the feeling that the world is hiding its most extraordinary places on purpose? Not behind tickets or fences, not behind money or borders, but behind distance, behind silence, and behind a quiet indifference to whether humans ever arrive at all. Most of the planet does not care if we see it. It doesn't advertise, it doesn't wait. It keeps moving, changing, and breathing. Long before we arrive, and long after we leave. Tonight, we step off the postcard map. We leave behind curated viewpoints and familiar icons. And instead, we enter Earth's back rooms, places where the planet is still actively writing itself. One eruption, one chemical reaction, one slow geological decision at a time. Picture yourself standing on a high ridge at dawn. The air is cold. The land is quiet. There are no voices, no engines, no signal bars on your phone. Just the faint sense that the ground beneath your feet is not as solid as it seems. Somewhere below you, heat is moving, pressure is building. This is Yellowstone, the world's first national park. And still one of the most radical ideas humanity has ever embraced. The decision to protect an entire wild system, not because it is useful, not because it is profitable, but simply because it exists. What many visitors never realize is that Yellowstone is not just scenic. It is alive in a way that most landscapes are not. Beneath the forests and valleys lies a volcanic hotspot of staggering scale. 3 ancient supereruptions once tore through this region, reshaping half of North America, altering global climate patterns. Those events are long past, but the engine never shut down. Today, that immense power escapes more subtly, through steam vents, through bubbling mud, through more than 10,000 hydrothermal features scattered across the park. Hot springs, fumaroles, mud pots, and the greatest concentration of geysers anywhere on Earth. Old Faithful may be the most famous, erupting with dependable rhythm, but it is only one voice in a vast subterranean conversation. Each geyser pulses like a valve in the planet's plumbing, opening and closing according to pressure, heat, and time. As we drift over mineral terraces stained in blues, greens, and fiery oranges, it's tempting to think of them as decoration. But these colors are not minerals alone. They are alive. Heat-loving microorganisms thrive here, arranging themselves into bands according to the precise temperatures and chemical conditions they can survive. Each ring of color marks a boundary, too hot to cross, too cold to endure. To me, this is one of Earth's quiet masterpieces. Life not merely surviving extremes, but transforming danger into structure and chaos into pattern. What looks like abstract art is actually biology drawing a thermal map of the volcano below. An invisible force made visible through color and motion. From North America, our journey crosses the Pacific Ocean to Indonesia, where the planet experiments with color in a very different way. In central Flores, 3 crater lakes sit side by side on the slopes of Mount Kelimutu. At first glance, they appear calm, almost ordinary. But nothing here stays the same for long. One lake may glow bright turquoise. Months later, that same water turns deep black. Nearby, its neighbors shift between jade green, rust red, and pale blue. Scientists understand the mechanisms: volcanic gases rising through the water, minerals dissolving, acidity levels changing. But prediction remains impossible. In one 11-month period, observers recorded 6 distinct color changes across the 3 lakes. No warning, no schedule. As if the volcano were quietly adjusting filters on its own private screen. Local communities interpret these changes through a different lens. They believe each lake reflects the fate of human souls, separate destinations shaped by moral balance. Whether or not you share that belief, it's impossible to stand at the rim without sensing restraint. People move carefully here. They speak softly. Kelimutu does not demand understanding, but it does demand attention. Beauty, however, is only one way the Earth hides its masterpieces. Sometimes it uses hostility. Descend below sea level into Ethiopia's Danakil Depression, and the planet feels openly unwelcoming. The air burns with sulfur. Salt flats stretch to the horizon, fractured like broken glass. Pools of acid glow neon green and yellow under temperatures that regularly exceed 45 degrees Celsius. In places, the water is acidic enough to damage skin, and yet life survives. Extremophile microbes cling to existence here, forcing scientists to redefine the boundaries of habitability itself. From above, Danakil looks less like geology and more like a laboratory accident, which is exactly why planetary scientists come here to rehearse for other worlds. On another volcanic flank in Indonesia, danger reveals itself after dark. At Kawa-Ijen, electric blue flames lick the night air. This is not fire in the traditional sense, but sulfur gas igniting as it escapes the crater. Nearby lies a turquoise lake of deceptive beauty, one of the most acidic bodies of water on Earth. For decades, miners carried solid sulfur from this crater by hand, trading their health for survival. Today, regulations limit that work. But the lake remains, quiet, steaming, a reminder that fascination and danger often share the same frame. Far to the north, Iceland offers a colder expression of the same creative force. At Svartifoss, hexagonal basalt columns rise behind a thin white waterfall, like the pipes of a frozen organ. These shapes formed when lava cooled slowly, cracking with mathematical precision. As Arctic light shifts across the gorge, the rock transforms from gunmetal gray to deep blue to silver. A small waterfall becomes a lesson in time, in patience, and in pressure. Across all of these places, one truth becomes clear. Landscape is not a static thing, it is a process. Heat moves, gases rise, plates drift, water erodes, and we arrive only briefly, stepping into the middle of a sentence that began millions of years ago. Which leaves us with a question that will echo throughout this journey. If the Earth can express this much creativity, where almost nobody goes, what else is it doing when we aren't looking? If fire is the planet's oldest language, then water is its most deceptive. We think we understand water. Rivers should be blue, lakes should be calm. Waterfalls should follow gravity in ways our eyes can predict. But some of Earth's most elusive wonders are made of water that refuses to behave. Water that bends rules, breaks expectations, and quietly rewrites what we think natural looks like. Deep in Colombia's Meta region, far from highways, far from crowds, a relatively short river winds through low sandstone hills. For most of the year, it looks ordinary, brownish, forgettable, easy to walk past without a second glance. Then, between roughly June and November, As the seasons pivot between wet and dry, something rare happens. The river changes character. Its bed ignites with color, as if the stone itself has learned to bloom. Locals call it Caño Cristales, the river of 5 colors. At first, people assume trickery, dye, minerals, reflections, but the truth is quieter. The secret is life. A fragile aquatic plant, Macarenia clavigera, exists only in a narrow window of depth, light and current. Too much water, it drowns. Too little, it dries out. Too fast, it tears apart. But when conditions align, the plant flushes deep red, threading itself through yellow, green, blue, and black algae. The river becomes a living spectrum, standing ankle-deep in it. The colors feel unreal, as if your eyes are malfunctioning. Protection here is strict, because fragility demands discipline. Visitor numbers are capped, boats are controlled, sunblock is banned. Guides are mandatory. In busy years, around 16,000 visitors arrive, not millions, not even hundreds of thousands. Because one careless step, taken at the wrong time, can crush the organism that makes the river possible. The first time I saw aerial footage of Caño Cristales, I remember thinking, this is what it would look like if the earth had veins made of stained glass. And it reminded me of something easy to forget. Scale does not equal importance. Some of the planet's greatest miracles are not massive. They are precise, temporary, and dependent on balance. We move north to Europe, where water plays a slower, quieter game. Plitvice lakes in Croatia appear gentle at first glance. Tiered turquoise pools, soft waterfalls, dense forest. Nothing dramatic, nothing aggressive. But beneath that calm surface, chemistry is constantly at work. The lakes sit on limestone. As water dissolves calcium carbonate, then redeposits it, the system builds itself. Natural dams form, shift, collapse, and rebuild. In some areas, new barriers appear within decades. Elsewhere, waterfalls vanish or reroute within a human lifetime. Here, water is not eroding the landscape, it is constructing it. Color changes follow suit. Sunlight, algae, minerals, microbubbles. Together, they push the water from milky turquoise to deep bottle green, then back again, sometimes in a single afternoon. On rare nights, visitors report faint glows when microorganisms or suspended particles catch stray light. It isn't fantasy, it's what happens when physics, biology, and geology share the same stage. On the opposite side of the planet, Australia offers no subtlety. Lake Hillier is pink, not seasonally, not occasionally, always. A narrow strip of sand separates it from the deep blue Southern Ocean, creating a two-tone landscape that feels almost artificial. The color comes from salt-loving microorganisms, algae and bacteria, producing red pigments to survive extreme salinity. Unlike other pink lakes, Hillier keeps its color year-round. Even when water is removed, it stays pink. A reminder that life does not ask permission, it adapts. In Tanzania, water becomes openly hostile. Lake Natron is shallow, extremely salty. Surface temperatures can reach 40 to 50 degrees Celsius. The water is so alkaline, it can calcify the bodies of birds and animals that die within it, preserving them in unsettling detail. And yet, this same lake is the primary breeding ground for millions of lesser flamingos. They feed on cyanobacteria that thrive in the heat. From above, natron shifts between blood red and patchy pink, depending on algae blooms and evaporation. The first images feel unreal. The first realization that an entire species depends on this environment forces a rethink. Maybe hostile is a word we invented for places not built around us. In California, the lesson is quieter. Mono Lake is ancient, tens of thousands of years old, with water several times saltier than the ocean. No fish survive here, but billions of brine shrimp do, and vast swarms of alkali flies. Together, they support millions of migratory birds. When calcium-rich freshwater springs rise into the lake, they form tufa towers. Jagged white spires emerge from the water, like ruins of a submerged city. In the 20th century, water diversion projects nearly destroyed this ecosystem. Mono Lake came close to collapse. What saved it was attention, law, time, and persistence. Today, it stands as a rare example of large-scale ecological recovery. Not all water mysteries announce themselves with color. In Minnesota, the Brule River meets something stranger. At Devil's Kettle, one branch of the waterfall behaves normally, flowing downstream. The other vanishes into a hole. For decades, people dropped in dye, sticks, even GPS-tagged devices. The water disappeared. Only recently did scientists confirm it re-emerges downstream through cracks, porous rock, and underground channels. The mystery is mostly solved, but the fascination remains. We are drawn to places where reality briefly misbehaves, even after explanations arrive. Along rugged coastlines, the ocean offers one last illusion. Blue holes, perfect circles carved into limestone, visible from the sky, dark against lighter water. At the rim, they glow turquoise. At the center, they fall into near black. At high tide, waves push water through underwater arches, producing low, hollow sounds, as if the sea itself were breathing through stone. Across all of these places, water does more than reflect the sky. It records chemistry, it reveals time, it exposes adaptation. And sometimes, rivers disappear, simply because rock, under pressure and time, gave them another path. The more we observe these misbehaving waters, the clearer the pattern becomes. The moment our curiosity finally catches up with what the planet has been doing all along. Leave the water behind, and the world seems to dry out. But it doesn't get any simpler. In fact, some of the most baffling patterns on Earth are carved not by floods, but by absence. Absence of rain, absence of soil, absence of anything soft. Where water withdraws, stone begins to speak. In western Madagascar, an eroded limestone plateau rises like a frozen forest of knives. This is Tsingy-de-Bemaraha. Over millions of years, slightly acidic rain has eaten into thick carbonate rock, slicing it into blade-like ridges that can reach 70 meters high. The local word tsingy loosely translates to where one cannot walk barefoot. That is not metaphor. The stone here is sharp enough to cut skin, to shred shoes, to punish mistakes. Between the pinnacles, deep crevices open into shadow, caverns, vertical corridors, stone mazes. Many remain unexplored. Life has adapted to this three-dimensional puzzle. Lemurs, reptiles, plants, all navigating a landscape with almost no horizontal ground. Suspension bridges now allow small groups of visitors to cross the upper levels. Below them, much of the interior remains untouched, sealed off by danger and by necessity, because this place does not forgive intrusion easily. Far to the southwest, on the edge of the Namib Desert, another landscape tells a quieter story. Devle. Once, a river reached this clay pan. It fed an acacia forest. Then, the dunes moved, the water withdrew, and the trees died, but they did not rot. The air here is so dry that their blackened trunks have stood for 6 to 7 centuries, unchanged, unfallen, suspended in time. Around them, sand dunes rise nearly 300 meters high, glowing deep orange against a sky so blue it feels artificial. Black trees, white clay, red sand. The contrast is so extreme that cameras often fail to expose it correctly. To stand here is to feel like you've walked into a paused scene. Across the Namib, another puzzle repeats itself. Fairy circles, perfectly round patches of bare earth, 2 to 15 meters wide, scattered across grasslands in eerily regular patterns. From the air, they resemble polka dots painted onto the desert. Theories compete. Termites, engineering moisture reservoirs underground. Plants, self-organizing to survive scarce water. Or both, locked in a long negotiation. Whatever the final answer, each circle represents a compromise between life, soil, and water in one of the oldest deserts on Earth. On the high plateau of the American Southwest, stone takes on a different personality. At a formation known simply as the Wave, ancient sand dunes nearly 200 million years old have been turned to rock. Then sculpted again, by wind, by rain, by patience. The result is frozen motion. Ripples of stone, curling, tilting, looping. Iron oxides, manganese, and trace minerals tint the layers red, orange, yellow, and sometimes purple. Standing inside the wave, many people report a strange sensation. Not fear, not height, disorientation, because every surface curves, every line bends, the ground, the walls, the ceiling. It feels like standing inside a painting that forgot it was ever flat, because the sandstone is fragile and erosion never stops. Access is tightly controlled. A daily permit lottery. Some find that frustrating, but it is bluntly necessary. One careless crowd could erase what took millions of years to form. Far to the north, China's Zhangye pushes color to a monumental scale. Entire mountain ranges glow with layered reds, yellows, and blues. Sedimentary rock, laid down over tens of millions of years, was lifted upward, then carved again by rain into ridges and gullies. Iron and trace minerals supply the pigment. Erosion supplies the brushstroke. At sunrise and sunset, the hills appear to ignite. Each ridge catches light differently, shifting hue by hue as the sun moves. From afar, the landscape looks rendered, too clean, too vivid, to be real. Up close, it's dust, gravel, wind, silence. Back in North America, any remaining illusions about time are stripped away completely. The Grand Canyon. Here, nearly 2 billion years of Earth's history are exposed in cross-section. Ancient metamorphic rock at the base, younger sedimentary layers above, stacked like weathered books. The Colorado River, often visible only as a thin thread, has cut more than 1.5 kilometers down through the plateau. On some days, temperatures at the bottom exceed 37 degrees Celsius, while snow clings to the rim above. A 25-degree difference compressed into a single vertical line. The canyon has become a symbol, a test of endurance, a sacred place for multiple native communities. But long before posters, before postcards, before admiration, it was simply an accident. Uplift, climate, time, proof that given enough patience, water can carve through continents. In central Turkey, the same ingredients produce something stranger: Cappadocia. Soft volcanic ash and tuff are capped by harder basalt. Wind and rain remove the weaker layers, leaving behind pillars. Fairy chimneys. Some rise 30 to 40 meters high, topped with stone caps like helmets. For centuries, people carved into these towers, homes, churches, dovecotes, entire underground cities linked by tunnels. At sunrise, hot air balloons drift above the valley, passing rock forms that look less like geology and more like an abandoned sculpture garden. On the Philippine island of Bohol, pattern reaches repetition. Chocolate hills. More than 1,200 nearly conical hills, mostly 30 to 50 meters tall, rising from a flat plain. In the dry season, the grass turns brown, and the landscape resembles rows of wrapped chocolates. Most geologists agree the hills began as marine limestone, uplifted, then weathered by rain. But the uniform spacing, the consistency of shape, remain difficult to explain fully. From the air, the scene looks generated, as if an algorithm was told to repeat the same idea until it ran out of space. If there is a theme running through these stone landscapes, it is this: pattern does not require intention. Humans are wired to ask who built this. The truth is more unsettling and more impressive. No designer arranged the fairy circles, no sculptor carved the wave, no engineer aligned the chocolate hills. Earth, left alone with enough time, produces complexity that rivals architecture, and what we see is only the surface. Below it, water seeps, minerals recrystallize, stress accumulates, then releases. Every canyon, every desert, every stone forest is the visible tip of a process that never stopped running, even when no one is there to witness it. So far, we've explored places that seem indifferent to whether anything lives there at all. Now, we turn to landscapes where life has made a dangerous bargain with extreme conditions, places where survival is not guaranteed, and where our own decisions, for better or worse, have become part of the system. Off the Horn of Africa, in the Arabian Sea, lies the Socotra archipelago. From the air, its plateaus and limestone cliffs look harsh, almost lunar. Up close, you realize something unsettling. You are walking through a botanical time capsule. Roughly a third of Socotra's plant species exist nowhere else on Earth, including the dragon's blood tree, with its inverted umbrella crown and deep red resin. It looks like something left behind by another era. But these trees are more than visual icons. They function as living infrastructure. Their wide canopies capture fog and rare rain, funneling moisture down their trunks into thin soil, onto bare rock. They keep other plants alive in a place that offers very little mercy. Recent research and local conservation work, however, has revealed a warning. Many dragon's blood stands are overmature. Young trees struggle to survive. Grazing goats, stronger storms, rising heat. Without intervention, models suggest large parts of this living forest could collapse within a few centuries. Standing beneath a dragon's blood tree, you feel two emotions at the same time: optimism and urgency. On one hand, local families run small nurseries, raising seedlings behind simple fences to keep goats out. On the other, each sapling takes decades to become a functioning water tower. For Socotra, later is no longer an option. The future of the island is being negotiated right now, one planting season at a time. Thousands of kilometers west, another living system stretches beyond easy comprehension. The Amazon rainforest, spanning 9 countries, it is often called the lungs of the planet. Scientists will tell you its net oxygen contribution balances out over time. But the metaphor still matters, because the Amazon stores staggering amounts of carbon, regulates rainfall across an entire continent, and hosts perhaps 3 million species, many of them still unnamed. When large areas burn or are cleared, that carbon is released. Rainfall patterns shift. In 2024, parts of the basin suffered extreme drought and record wildfires. Other regions, at the same time, showed hopeful declines in deforestation, driven by targeted protection. From orbit, the forest looks endless. From the ground, the scars are impossible to ignore. Blackened trunks, drained wetlands, silence, where insects should be loud. And yet, resilience persists. Indigenous patrols monitor boundaries. Scientists track tree growth in long-term plots. Communities explore economies that keep the forest standing. The Amazon is no longer just a wilderness. It is a negotiation. Out in the Pacific, that negotiation becomes visible underwater. The Great Barrier Reef stretches more than 2,300 kilometers along Australia's coast. It covers hundreds of thousands of square kilometers, a living mosaic of reefs, islands, and cays. Thousands of fish species, hundreds of corals, turtles, sharks, rays, migrating whales. From space, it looks like a chain of turquoise bruises along the continent's edge. Up close, in healthy sections, it is a 3-dimensional city, alive with motion. But the reef has also become a global diagnostic tool. Over the past 3 decades, it has lost roughly half its coral cover. Marine heat waves, storms, pollution, outbreaks of crown-of-thorns starfish. In 2024, a mass bleaching event killed corals at catastrophic rates in some shallow areas. Drones recorded mortality above 90%, and yet other sections recovered during cooler years. A reminder that given a window of relief, life fights back. The reef forces us to abandon a comforting illusion. A natural wonder is not a postcard. It is a heartbeat trace. Peaks, crashes, fragile recoveries, and our choices on land, in the air, upstream, show up directly on that line. At the opposite end of the climate spectrum, ice tells a colder story. In Greenland, Ilulissat Isfjord funnels a fast-moving glacier straight into the sea. Sermeck produces roughly 10% of Greenland's icebergs. Tens of cubic kilometers of ice break free each year, the equivalent of thousands of office towers silently collapsing into the ocean. The ice front creaks, roars. Some bergs roll as they carve, sending waves across the fjord, revealing cross-sections of ancient snow compressed into blue glass. Scientists treat this place as both hazard and library. The ice stores centuries of climate data in trapped air bubbles. The glacier's retreat provides a live experiment in how warming reshapes coastlines. Local communities see it differently. They don't read graphs, they read timing. Sea ice forms later. Fish move differently. Travel becomes riskier. Change here is not abstract. Farther south, in Antarctica, another extreme waits. The McMurdo dry valleys, no rain, almost no snow. Katabatic winds strip moisture away, leaving bare rock and frozen salt lakes under constant cold. NASA tests Mars rovers here because the environment resembles other worlds. Life exists, but in slow motion. Microbes beneath the surface, thin mats on stone. Entire ecosystems sealed under ice. In the tropics, a different kind of sensitivity reveals itself at night. Mosquito Bay, in Puerto Rico. On certain evenings, each paddle stroke ignites neon blue light. Bioluminescent dinoflagellates, tiny plankton, flash when disturbed. Under the right conditions, temperature, salinity, moon phase, the bay becomes the brightest bioluminescent bay on Earth. Disturb the balance with pollution, boat traffic, coastal development, and the lights fade. In Canada, winter seals another lesson beneath the ice. Lake Abraham. As plants decay on the lake bed, methane bubbles rise, then freeze in layers, white disks stacked in clear blue ice. A natural laboratory for greenhouse gas research, and a scene that feels borrowed from science fiction. Not all edge-of-the-world wonders are purely natural. Some exist where human culture and extreme landscapes collide. High in the Peruvian Andes, Machu Picchu rests on a narrow ridge. Precision-cut stone blocks fit so tightly no blade slips between them. A design that absorbs earthquakes and drains water rather than fighting it. Terraces stabilized slopes, fed crops, and prevented landslides. Rediscovered in 1911, it is now both an engineering marvel and a stress test for modern tourism. Off Ireland's west coast, Skellig Michael rises like a jagged tooth from the Atlantic. Monks once climbed more than 600 exposed steps. To live near the summit, they harvested rain, stored food, accepted isolation. Today, strict visitor limits exist, not only to protect stone and seabirds, but to honor the truth. This was never meant to be easy ground. In Vietnam, Phong Nha Ki Bang hides vast cave systems inside ancient limestone. Underground rivers, colossal chambers, delicate formations. Some passages are large enough to swallow city blocks. These caves store climate records and shelter species evolved for darkness. Tourism here is zoned carefully, income balanced against preservation. On the East African plains, the Serengeti reminds us that some wonders are not places. They are processes. More than 1 million wildebeest, zebras, and predators cycle across the land. Each river crossing is hesitation, panic, and sudden motion. A living equation that only makes sense over time. Off Ecuador's coast, the Galapagos Islands show what isolation can do. Volcanic terrain, time, limited arrivals, evolution unfolds in public view. Strict quotas, biosecurity checks, and zoning acknowledge a simple truth. These islands cannot afford our mistakes. At the border of Zambia and Zimbabwe, Victoria Falls brings the message home. More than 1.7 kilometers wide, a drop of roughly 108 meters in high water, over 500 million cubic meters of water per minute, smoke that thunders. Standing at the rim, faces wet with mist, many feel the same thing: exhilaration, unease, scale, and finally, the pattern becomes clear. The world's secret wonders are not hiding from us. They are remote because that's where the conditions aligned. They remained obscure because they didn't fit our old travel maps. The uncomfortable truth is this: we are now inside their stories. Our emissions shape reefs and ice fjords. Our consumption ripples into forests and savannas. Our posts can turn quiet places into viral pilgrimages. But there is a hopeful truth too. We can choose differently. When we protect and follow through, ecosystems respond, corals recover, forests stabilize, migrations continue. Local communities find ways to host visitors without being erased. If there is one takeaway from Earth's hidden masterpieces, it is this: we are not the main characters. We are the latest guests. Every dragon's blood sapling planted, every controlled burn done right, every reef protected, every cave or canyon kept within limits is a vote for stewardship over extraction. So the next time you see a rainbow river, a glowing bay, or a canyon you've never heard of, treat it as more than scenery. See it as an invitation, not just to travel, but to protect. Because preserving culture, respecting communities, and defending green and blue spaces from short-term gain is not about saving pretty landscapes. It is about ensuring that a living, creative planet is still here, still surprising us for generations who may never know how close we came to losing it. Across all these places, rivers of color, stone forests of knives, glowing bays, melting ice, and migrating life, a single truth becomes impossible to ignore. The world's greatest wonders are not hiding from us. They were never meant to be easy. They exist where geology, climate, and time briefly agreed to allow something extraordinary. The uncomfortable truth is this: we are no longer observers. We are inside the story. Our emissions warm reefs and glaciers. Our consumption echoes through forests and savannas. Our curiosity, shared carelessly, can turn silence into pressure overnight. But there is another truth, one we often underestimate. When humans decide to protect and actually follow through, the planet responds. Coral grows back, Forests hold their ground. Migrations continue. Cultures remain rooted instead of erased. This tells us something vital. We were never meant to dominate this planet. We were meant to belong to it, carefully, temporarily, responsibly. We are not the main characters here. We are guests, and guests have choices. Every sapling planted, every reef left unfished, every canyon capped at capacity, every cave left dark is a quiet decision to stay longer without taking more. So the next time you see a rainbow river, a glowing bay, or a place you never knew existed, don't ask how fast you can get there. Ask something harder. How do we make sure it is still here, still alive, still undiscovered? For those who come after us. Because in the end, protecting these places is not about saving beauty. It is about preserving a living planet that still has stories left to tell. And if you want to keep discovering them, one hidden place at a time, subscribe to this channel and turn on notifications so you never miss anything extraordinary.